In our last class, we talked about how we can resolve vectors and how we can resolve vectors into different components. And we also say we can also determine the resultant of more than two vectors using resolution method. And we listed the steps that we must follow. Remember, the first step you make sure you resolve each of the vectors to their various components, their x and y components. You know how to do that. And secondly, you should also do what? Add all those vectors, that is all the x component, add them together to form a new vector rx. Add all the y component to form a new vector ry. Then after that, you can determine the real resultant using your what? Pythagoras theorem. And you can also determine the angle of that resultant, that is the direction of that resultant from there. Now we want to solve this question, question 2.4, example 2.4. Determine the resultant of the system of forces in the figure below. Determine the system of forces, the resultant of the system of forces in the figure below. I label each of the forces, I label them called alphabetically. I put A, B, C, D, E, F. A might be maybe Abe, Biodun, Caroline, Dotun, Ebenezer, and Femi. Look at them, and what? Gold. All of them, they are trying to drag a table. Look at this table. Let's say this is a table, center O, with different various forces. See, we have 10 Newton, this one pulling with 6 Newton, this one pulling with what? 10 Newton, 20 Newton, and so on. Now the question is, where will this table, where will it shift? Where will it shift to? And the question is, what particular force will make it shift, and what direction will it shift? That is the meaning of resultant of all these forces. And to do that, remember, I told you have to resolve each of them. Let's see. Solution. We have to resolve each of the vectors into their various two components. Vector A, talking about for A. For A is 8 Newton. 8 Newton is already on vertical components. You don't need to resolve. Therefore, your AY is 8 Newton, but your AX is 0, as it doesn't have any component on x axis, like on the horizontal axis. For B, B is on neither axis. It doesn't belong to any of the axes. This is vector B, which is 10 Newton. You can see, and it makes an angle 30 degree with the horizontal, angle 30 degree with the horizontal. So this is where it's starting, and this is where it ends. That is why I will trace it, give it arrow here, then trace it up to know the vertical, and give it arrow. So this means that this place will be the vertical, which is BY, and the horizontal, your BX. This is the opposite, and that is why BY will be B sine 10 degree. 10 Newton. Sorry, B sine 30 degree. Our angle is 30 degree, and that is why it's opposite. And what is our B? Our B is 10 sine 30 degrees. 10 sine 30 degrees. Sine 30 is 0.5 times 10 will give us 5 Newton. Also, we can get our B. Our B is, this is our BX. BX is going to be the adjacent, which is B cos 30. And BX will give us 10 cos 30. Cos 30 is 0.8660, that is root 3 over 2. This cancel this, and that's going to give you this 1.732 times 10 will give us 8.66 Newton. 8.66 Newton, and that is our BX. That is for vector B. We can do for vector C. For C, okay, let's move to that side. Okay, for C, for C, where we have vector C 6 Newton in this direction. Vector C is 6 Newton. You can see down direction, something like this. This is our C, which is 6 Newton. Our C is 6 Newton, making an angle 45 degrees with the horizontal, 45 degrees. So automatically this is the adjacent, this is the opposite, and this is our BX, this is our BY. I say B, CX, and this is our CY component. CX and CY component. CX is opposite of cos 45 or 45, so that's why we have C is 6 sine 45 degrees. Sine 45 degrees is root 2 over 2. If you do 6 times sine 45, it will surely give us 4.2 or 4.24 Newton. Similarly, your CY would be CY is equal to, your CY would be equal to C cos 45 degrees, and that's going to be what? 6 cos 45 degrees. It's going to give us the same answer because sine and cos of 45 is the same, and this is still going to be 4.24 Newton. Mind you, where does this vector start from? It starts from here, going down. So that is why we have to trace this thing downward, and that is why the arrow here for CY, the arrow for CY is tending downward. Our arrow for CY is tending downward, and so that this one will also tend in this direction. And that is why our CY is negative. Our CY is negative y-axis, downward. Our CY is downward, while CX is positive x-axis, and that is why this one will be negative. Now we can move to vector D. Vector D, you can see, vector D is tending downward, and that is on vertical component, downward vertically, and that is 10 Newton, your vector D. Your vector D. It means that dx is 0. Doesn't have any component on x-axis, that is on horizontal axis, but it has component dy, vertical component, as minus 10 Newton. It's negative. It's negative, tending downward. 20 Newton, that is your E. Vector E, moving this direction. For this vector, is making angle 30 degrees with the horizontal. We can trace this one so that we trace it from here, trace it down, or if you like, yes, let's trace from here and trace it down. Trace it down. This is our vector E. Our vector E is 20 Newton. Trace it down. This one will be what? E. This is EY, downward. This is downward, you see, it's coming down. Why is it coming down? Because it has to start from here and come down, and that's why this one is also moving in this direction. So this is our EY, this is our EX, and this is our EY. How do we get our EY? EY is equal to, this is opposite, and that is why we have E sine 30, opposite to the sine. Our E is 20 sine 30. Sine 30 is 0.5 times 20 will give us 10 Newton. But we are going to make it negative. Negative 10. Why is it negative? EY is negative. Why? Because it's tending downward y-axis. It's tending to the negative y-axis, downward. Similarly, our EX is equal to E cos 30, and that is also going to be negative, which is going to be minus our E is 20 cos 30. Cos 30 is going to give us 0.8660, which is going to give us 20 times 0.8660, and 20 times 0.8660 will give us minus 17.32 Newton. Minus 17.32 Newton. Why is it negative? because the direction is towards negative x-axis. Negative. You see, if you have something like this is your positive y, this is your positive x. This is negative x, this is your negative y, downward. Left is your negative x. Take note of that. Remember that this is the convention we are making you sign convention of. Now for f, without any problem or without even having any issue, we have 4 on x-axis, and that is why for f is like this, 4 Newton. That is your f, and that is why f only have horizontal component fx, which is 4 Newton, but no vertical component, which means fy is 0 Newton. Why is it going to be ordinary 4? Can it just be ordinary 4? No, because it's going in the negative x-axis. That is why this one will be what? Minus 4 Newton. Now, lastly, we have our 2 Newton, which is our g. For g is moving in this direction. G, which is 2 Newton. 2 Newton, making an angle 60 degrees. 60. So, automatically, this one will move in this direction to go and meet up. To go and meet it up, which is 2 Newton. And that is why this one will be positive, but this will be negative. So we can have your g, this is our vector g. Your gx is 2 cos 60. I hope you know why it is 2 cos 60. This is adjacent of 60, this is opposite of 60. Why gy will be equal to 2 sin 60. It means your gy is equal to 2 sin 60. 2 sin 60 will give us 1.732. That is your root 3 over 2 positive. While your gx is 2 cos 60, and that's going to give us 1. 2 cos 60 will give us ordinary 1 Newton. And that is all. We have already resolved every of the vector, each of them. We have resolved each of them to both vertical and horizontal component. The next thing we need to do now is step 2, which is add. Step 2 say we should do what? Step 2. Step 2 say we should add all the x component to form 1. Add all the y component to form another 1, which is your rx will now be addition of all the x components, summation of x components. That is your new vector rx. And how do you do that? Summation. Let's start from the first one. A does not have any x component. That is 0 plus. For B, the x component of B is 8.66 plus. For C, 4.2 plus. For D, no x component, 0 plus. For E, minus 17. So this one will be minus 17.32. For F is also negative, minus 4. Then for G is 1, that is plus 1. If we add everything together, we will get a value, and our ry, we can also do that the same method, summation of y components. Let's pick that one by one. Our y components, the first value, let's go to A. For A, ay, which is 8 Newton plus. For B, by is, where's our by? Our by is 5 Newton. This is our by. Is 5 Newton plus our cy. Your cy is 4.24 Newton or 4.2 Newton. That's our cy. Then let's go to our dy. Our dy is negative 10 Newton. That is why we have negative 10 Newton. And our ey is also negative 10 Newton, our EY. Our EY is negative 10 Newton. That is our EY. That is for E. Then for F, our Fy is 0. 0. And for G, our Gy is 1.732. Now let's have result for Rx first.
Minus 7.46.
Minus 7.46 Newton. That is our Rx. And let's have result also for Ry.
Minus 10.6.
Minus 10.6 Newton. What does this mean? 6.8 Newton, which is, let's say, 7 Newton. So we have already found the x component and y component of our resultant. We can now draw the enlarged, that is, the new diagram we have. The new diagram, the figure we have here, we can resolve it. We can now have the new diagram, that is the simplified diagram. Simplified is going to be, one is moving in negative x component, which is negative like this, negative in this direction, which is minus 7 point, not this time around, it's not going to be minus again, there is going to be your Rx. Rx is 7.46. I've already put it in the negative y, negative x direction, that's why I don't put minus again. Then for the other y component, that one is moving, this is our Rx. Rx, right. This is our Rx, which is 7.46 Newton. And our Ry is also moving down. I hope you know why it is downward, because it's also negative. It's also negative, which is minus. That's your Ry is going to be 10.7 Newton. Assuming I take it up, that's when I'll put this minus. Now we can also determine our resultant, the real resultant, that is the overall force which we are looking for. That's our resultant. And we can determine what angle is making with x component. What angle is it making with x component? Let's call it theta. You can determine that too using your Pythagoras theorem. R square, which is the resultant, the magnitude of resultant, we can find R square is equal to Rx square plus Ry square, which is going to be 7.46 square plus 10.7 square. That's our R square. Then it means R will be square root of 7.46 square will give us what?
55.65.
55.65 plus 10.7 square will give us
114.49.
114.49. Now if we take the square, if you add these two together, please add it together.
170.14.
170.14. And if you take the square root, what do we have? Just
13.04.
13.04 Newton. What do we mean by this? It means that all these forces we have here, the only effect on this table is 13.4 or 13.04 Newton. And the direction with which it will move is this direction. And let's see that direction. That angle theta tan. Theta is equal to opposite 10.7, which is your Ry over Rx. So it means that theta will be equal to tan inverse of your Ry over Rx, which is tan inverse of our Ry is 10.7 all over Rx is 7.46. Find the tan inverse of that. If you find the tan inverse of that, we have 10.7 divided by 7.46. Find that, then we take this tan inverse, that is shift tan of our answer. That is tan inverse of 1.4343, and that will finally give us 55 degrees. 55 degrees. So it means that the resultant of this force, we can conclude that the resultant of everything we have here, resultant is what? The resultant is 13.04 Newton at an angle 55 degrees to the horizontal. Thank you very much.